Let's talk about PLC memory. If we're talking about a PLC, we're also talking about a computer. Why? Because a PLC is a computer and it has a memory area. So let's talk about memory. So let's look in our memory area of this CPU. And inside this box, inside the CPU, we have a dedicated memory area. And as we look at this dedicated memory area, it is fixed. It cannot be changed or adjusted in this application. It's fixed. And once this memory area reaches capacity, we're out of memory. So let's look at this block. This block is going to represent a single bit for us. This is our single bit. It's a block. And that bit can have a value of 1 or, not and, 1 or 0. Some may refer to that as on, if it's a logic 1, and off, if it's a logic 0. You may also hear the terms high or low. So within our memory, we will have an array. We will have a lot of bits within our memory. So we put a single bit in, and for now, that single bit will represent multiple bits that are placed in our memory, and we use these bits and a combination of off and on instructions within our bits to control our camera, our phones, and even now automobiles if you think about Tesla. As we need to create more complex applications, we can take a grouping of 8 bits, and when we group 8 bits together, we create what is known as a byte. So 8 bits make up a byte. So if we look at this byte, our byte, if we look at this byte, our byte again is made up of 8 bits. And if we take a look at the orange block, the bit on our left, this is going to be bit 0 within this byte. And then the yellow block at the end is bit 7. They do not all have to be high at the same time or low at the same time. And I'll use the terms off at the same time or on at the same time. They can be controlled by the logic that you create for your system. They are controlled by the logic that you create for your system. Bit, byte. Next, we'll talk about the word. So now we look at a word, and a word is made up of 16 bits, 16 individual blocks that can be 1 or 0, high or low, off or on. And if we take a look at our word, within that word, we have byte 0 and byte 1. As we look at byte 0 and byte 1, we start with bit 0 and we end up at bit 16. There's 16 bits, and again, we always start with 0. And all of this, all of our memory units, our logic, and our data continues to go within our memory area. As we continue to fill our memory area, we use the capacity, we use the fixed capacity that we have, and at some point, we will use our dedicated memory fully. So now we have now the double word. A double word is composed of 32 bits. Please work with me on the handwriting. 4 bytes. This is 4 bytes. So again, we have 32 individual bits that can all be high or low, off or on. It's a double word, 32 bits, 4 bytes. This is byte 0. Also, we have within byte 0, bit 0 through bit 7. In word 0, we have bit 0 through bit 16. And we also have within word 0, byte 0 and byte 1, byte 2, and byte 3. All of this data, this logic can be put into our CPU in our memory area until we reach capacity. And we can see now, since we're not at the point of capacity, we can move our memory around. Our device, phone, because it's full of pictures, our computer is not slowing down. We can move things around readily. Let's see what happens as our memory fills. So we've crammed a lot of logic in our CPU. We've created a lot of data in our CPU, and we're almost at capacity. So if you notice that as I reach capacity, I have less options for data structures. I have less options for, if it's your phone, memory. I have less options. My device is slowing down because I have so much data crammed in. There's not much room to move. And at that point, again, as I look at my CPU, this could be your PLC, this could be your phone, this could be your car. As we reach memory capacity, things start to slow down because we have less flexibility in our movements. This is your CPU, your memory, you have the bit, a single unit, you have the byte, can't find my word, you have the word, you have the double word. You also have integers, you have reals in your data structures, and also depending on the system you're working with, Allen Bradley or Siemens. In Siemens, you have the single bit is called a bool, the B-O-O-L, and Allen Bradley, it's a bit. Have a good day. Shan Smith, Good Sense Automation. If your CPU's memory is full, however, there are options for what to do. If our memory is full, we can have additional storage or additional memory, and we can take some of that data and put it into that additional memory area. So we have to think about our application, what we're going to use the system for, and think about, if it's a PLC, the number of IOs in the beginning of your engineering.